standardization of Biofloc technology towards sustainability in Indian aquaculture. And this is the flow of my lecture or the flow of my talk. First, I will start with the background. As you all know that aquaculture is very much important for food security and nutrition, economic and social benefits, and environmental sustainability. Presently, the position of India is good. It is the second largest fish producer globally after China, contributing 8.92% of the global fish production. In the inland sectors, India has shown an impressive growth from 7.5 lakh tons in 1950-51 to 139 lakh tons in 23-24, according to the Ministry of Fisheries, Government of India. Now, in all the aquaculture sectors, this is the ingredient of the normal fish production, where you use fish meal and other ingredients, as you can see from here. But in case of the Biofloc technology, it is really a revolution where the organic waste is converted into protein-rich biomass that serves as the natural feed for the fish and the shrimp. These are the ingredients for the Biofloc technology. The jaggery and the molasses are the sources of the carbon. The fish excreta, which is rich in ammonia, is converted into fish feed with the help of some microbes that are sourced from the probiotics. This is actually a picture where you see the fishes are consuming the Biofloc, and basic keynotes are the C and the N ratio. This is the basic feature of the Biofloc technology or the success of the technology. Molasses, jaggery are mixed at the rate of 250 to 500 gram per 1 kg of the feed to maintain a carbon to nitrogen ratio of 15 to 20:1 for Biofloc development. The benefits of the Biofloc technology are the feed conversion ratio and the growth rate, increase of the growth rate and the lowering of the feed conversion ratio. This is basically a circular ecology, which I will tell that why it is a circular ecology. But with this background, my objectives are to evaluate the success of Biofloc technology in nursery and growth systems. This is a view of the field where I have conducted my trials, and these are the candidate species in the nursery phase. My objectives are assessment of the growth and production performance of these fishes in the nursery ponds, then determination of the water quality, assessment of the health condition of the fishes in all the trial crops, and analysis of the economic parameters to determine the profitable options. Coming to the methodology, the entire experiment was carried during 23-24 at Naihati in 24 Parganas North. And this is the flow chart that how the operation occurred. The tank was filled and then the water was aerated. I mean to say that continuous aeration is needed for the Biofloc technology's success. And then the TDS, pH are adjusted, and all the jaggeries and all other ingredients are added in suitable quantity. This is the picture where I am using the feed in the Biofloc tank. And these are the environmental parameters that has been monitored simultaneously: water temperature, water pH, salinity, dissolved oxygen, alkalinity, nitrate nitrogen, nitrite nitrogen, ammonia nitrogen, and phosphate phosphorus, as per the standard technology as mentioned in Strickland and Parsons 1972. These are the biological parameters: daily weight gain, SGR, that means the specific growth rate, survival, and FCR. Lesser is the value of FCR, more is the success of the experiment. So with these indicators, the culture was conducted, and finally the benefit cost ratio was also evaluated. These are the fields works I have done during my trial experiment, and now I am coming to the success stories. You see the growth rate of all the species. In case of Katla, at a very minimum Biofloc concentration, 5 plus minus 2 milliliter per liter, the growth is maximum compared to other species. In case of Rohu, the same picture is repeated. In case of Mrigal, the picture has been reversed. The growth rate showed maximum at high Biofloc concentration at 15 plus minus 2 milliliter per liter. In case of Pangas, again, the lower Biofloc concentration gave the maximum growth rate. In case of Rupchand, also, again, the lower Biofloc concentration generated the maximum growth rate. But in case of Pineas venami, the shrimp, the picture has been reversed at growth rate. The growth rate is maximum at 15 plus minus 2 milliliter. These tables are the reflections of those graphs I have shown here. These are the reflections. Now the question arises that why this variation is the growth rate. This is because of the different food habit of the fishes. Species like katla, rohu, they are actually the surface feeders, but mrigal and the white shrimp, they are the bottom feeders, and that's why the difference has been seen in the growth rate pattern. Coming to the RY or the benefit cost ratio, you can see that in T1, T2, T3, the Indian major crops IMC, katla, rohu, and mrigal has shown the different amount of benefit cost ratio. Again, the operational cost of the pangas is also there. Then coming to the rupchand, then finally to white shrimp, Pacific white shrimp. We have seen that in all the cases, the benefit cost ratio is giving a very good output and reflecting that Biofloc technology is also economically viable. Coming to the summary, the number one is that optimum Biofloc level is needed for all the varieties of species, and this Biofloc concentration is species specific. The specific growth rate is seen in all the fishes, and it is also variable as per the feed habit of the fishes. The feed conversion ratio is also changing with time. Water quality stability has been observed with a high value of dissolved oxygen above 5 ppm, which is actually the success story of the Biofloc. The nitrogen cycling is very much viable and seen in the Biofloc technology, where the ammonia is not treated as the toxic substances, rather it is converted into feed, and finally it is converted into protein. This is basically the circular ecology what I was speaking about. The survival rates, the production yield was maximum in Biofloc technology compared to the traditional fish culture system, which has been shown through economic analysis. And finally, the environment and sustainability gains is also the bottom line story of Biofloc technology. As I have told us, it is a circular ecology. Why circular ecology? Because none of the excreta, which is the waste product of the fishes, rich in ammonia and is a toxic substance, is not there. It is converted into protein with the help of some microbes, and therefore it is a nature-based solution on and giving rise to low carbon footprints, which is the call of the century. Therefore, it is basically a nature-based solution and a revolution in the Biofloc, in the aquaculture system. These are the references which I have studied, and with this I thank all of you for giving me this opportunity. Thank you.